I presume everyone can hear me. We might start with a video here of some of our Antarctic equipment running, and then some of it will still self-tell the story to get us started. Whoops, go back. Right. We make that run. Come on, run.
Perhaps one of the greatest advancements in Antarctic scientific exploration.
Stopped it here.
Is the ability to economically and reliably transport large, heavy loads of equipment and supplies to remote inland study sites and stations. For the best part of 4 decades, Elphinstone Engineering's innovative, specialized, low-maintenance Antarctic equipment has paved the way in design and innovation by reliably transporting vital supplies through the Antarctic's harsh interior. Elphinstone's Antarctic designers participate in transverses to gain essential first-hand knowledge required to optimize payload capacity, decrease drag to reduce fuel consumption, and finally withstand the unforgiving Antarctic conditions.
That's one of our snow groomers. They're in operation. These are some of the sleds we built for the AAD 2020-21. We had 28 sleds. The video you saw before was part of the French IPEV operation, and they're travelling 1,100 kilometres inland up to the station at Concordia, which is 3,200 metres above sea level. The Australians are going into the same similar area, and theirs is about a 1,200 kilometre run. But we've been doing this with the French since 1993, so we've built a lot of experience out of that. And I've been fortunate enough to have done it 4 times with them on their traverses. This one here is an interesting one. We've got little air sleds front and rear of the Casbora there. You see the black spot out behind, that's a ship that's 75 kilometres out to sea across the sea ice. We built these units because they had 3 years in a row that they couldn't get into the base to bring fuel in. So we built these units so that if they happened to go through the sea ice, they would float the Casbora. And they have the fuel bladders behind them. This is an interesting here to see from an engineering point of view. Watch what happens when the tracks go over there. It's a crack in the sea ice. Watch when the bladders go across it. We actually designed the fronts of those carpets that the bladders are on as well. All right, so we'll get in probably. We've had all the experience, a lot of experience in Antarctica, but probably without our background in the log transport side, we wouldn't have the experience or the capabilities of manufacturing the Antarctic equipment. The Antarctic equipment about runs between 8 and 15% of our business, so it's not something you could set up just to run full time. But we build sleds, other support structures for containers, building support structures. We built heaps of things for the French and the Italians since '93. We've did odd things for the Australians over the years until 2020. We built 28 sleds for them and other equipment, and been building other equipment since then. and we've been supplying the South Korean traverse equipment maybe the last 8-10 years. All their equipment is 100% ours on their traverse operation, which also goes to Dome C. Now, we'll go into a little bit of history from our business. I started, I come from a farming background, and I made a career change in 1971, moved to Tribunna and became a faller, bushman falling trees. Started repairing my own chainsaws, and I only did 13 months at that, and I became a logging supervisor with the local chip mill and used to do welding repairs at weekends. So 3.5 years in the logging supervising, and then I started, the chainsaw business got too big to be a part-time business, so I started as full-time business. Probably we'll go through here. That's the first, I started importing on-vehicle weighing systems, so electronic on-vehicle weighing systems, 1976. My brother and myself. A little bit of history here that the local trailer manufacturer in Hobart at the time, we had a branch in Launceston and Burnie, were building a new trailer for a customer, and we went to them and said, how about fitting load cells into the trailer while you're building it? Their answer was, piss off with your toys, boys, you don't know what you're doing. So we did. When that new trailer went on the road, one weekend, my brother and myself fitted load cells, cut up this new trailer and put load cells in it. I went on retrofitting existing trailers, and as I'd done repairs before, when I started cutting them open to put load cells in them, I started to see why the failures had been there. So consequently, that's how I really learnt to design equipment. So 13 months after we put the first set of scales on, I had enough components, because customers have been saying, oh, build me a new bolster, build this part, build that part. So 13 months on, I had enough components to build a whole new trailer. So we put our first new trailer on the road, and then went on developing things over the years ever since. Built mudguard systems, improved cab guards, rubber-mounted cab guards. And in 1980, saw triaxle trailers instead of tandem trailers come in to vogue. And obviously we went on with on-vehicle weighing, and we've done a lot of development with that over the years, although the systems we had at that time were very accurate and probably as good as what we fit today. It come from the aerospace industry, and obviously we've went on developing more, but some of the basic load cells that we had then, what we fit on a fifth wheel on a truck at the moment, is still exactly the same design load cell. This is an example here of, I think it's 1981, 82. To stop overloading, when I was working with the chip mill, we had a problem with truckers overloading, the police policing them, and arguments all the time about they didn't have any ways of knowing what weight they had on. So myself and the logging supervisor at the time said, how are we going to rectify this? So we went to Transport Tasmania and said, if we as a company don't pay these people for overload, will you back off on the policing? Which they agreed to. And then it was like 2 or 3 years later, I started fitting on vehicle weighing. So it was 105 log trucks carting into Tribunna at the time. The people that told us to bugger off with our systems in 1976 and 1978 went to the States and brought the competitor brand of electronic scales and brought them in. Between us, by 1983, those 105 trucks were 100% fitted with on-vehicle weighing carted into Tribunna, which a lot of people don't realise. And this slide here shows some of the accuracy. Now, with their overload thing, they refined it a bit. This particular truck here was allowed 35.4 tonne legal. So the chip mill paid them up to 36 tonne. If they went over 36 tonne, they only got paid for 35,400. And you can see in here, this particular truck I pulled up one day, and I just jumped in his truck and grabbed 3 consecutive logbooks of 25 per load. So you can see the 75 loads, there's only twice that he was over 36 tonne in 75 loads. His average load, though, was 35,920. So he was loading within 100 kilos every load of what he was going to get paid for. And this is an 8-point system on a flour tanker that we did up in Queensland in 1982. We did a couple of them when we really set them up for really high accuracy. But if you look at the graph there, you've got the weighbridges on the orange line, in the scale, onboard scales, the blue line, and there's only a variation in there of about 21 kilos between the two. So we proved you can really make on-vehicle weighing super accurate if you want to. Probably this explains, people talk accuracies. We always sell to be plus or minus 1% of actual payload, but you can see there it's 410 kilos and a 41 tonne payload. There's bigger loads these days. And we consistently get down to 0.5% plus or minus in a general transport application. We can make it more accurate, or we can get more accurate if they do better with their managing fuel, because we don't actually weigh fuel. 1983, we developed our own triaxial suspension called Tri-Beam. Up till this time, the only drafting we had was just sketched out on paper. This particular one was the first time I'd ever used graph paper and dividers to do any design work in trailers. So this was done with just a piece of graph paper and pencil and a set of dividers. It's probably interesting to some engineering people. It worked very well, and you can probably see here from the video, it was very good for load sharing. You could lift any corner wheel 350 mil and it remained fully load sharing. You can't do that with the modern suspensions today. And you can probably see when it goes over, you can tell by whether the tyres squash. It's not carrying extra load on those individual axles. And it stays remarkably stable for what it is. Unfortunately, in early 92, 93, they brought out air suspensions and went to what they called road-friendly suspensions, which ours wasn't road-friendly in theory. In practice, I think it's no worse than any air suspension, but that's what they did, and they got 2.5 tonne more on a try than what we were. So we built 187 of those, and like I said, we did draw them out better. We ended up with a drafting table and manually drawn, but the total original drawings were all graph paper. Now, people go on about road trains. In 1983, we introduced road trains carting into Tribunna. Because triaxle trailers come in, there was a lot of old tandems sitting around, so we made up a dog trailer out of the second-hand tandem trailers, made the rear trailer fold up onto the front trailer, and it lifted the front axle, all mechanical, pushed up against a ramp, no hydraulics. There was 2 levers you pulled over centre, backed it in, backed it up the ramp, broke the pole, and it actually locked the axle up all in one operation. The same when they got to the bush to unfold it. They put the 2 levers over centre, and then it unlocked itself as the trailer unfolded off, and you only used the trailer brakes and we used a ramp or bank of dirt to load it on. The video here, this is coming down out of M Road, so we could run them down 80 kilometres down M Road, to the bottom end of M Road, and they would drop the dog there to come out onto the main road and bring it into the mill for the last 22 kilometres, and then go back with the empty truck with the jinker folded up and tow the dog trailer in. They were coming down there with about an 85-tonne gross load, and there was 83. We built 4 of those. Going back to the bush empty. This is my first go at videos. So we're doing this video about a folding skeletal trailer. So we use skeletal trailers for carrying short logs. So we come up with this idea in 1985 to fold it up. And I'm actually here trying to cover up some of our secrets of what we thought we had to make this load. I'll probably skip this. It's not my finest hour of explaining things. And so we built the world's first folding skell in 1985. Now, basically push it up the ramp. We have a pair of pole breakers, or beam breakers we call them, dropped in and locked the suspension in relation to the skell frame. Back at back, we had to get a bit of a knack, pull the trailer brakes on and get it push up. Bolsters fold over, totally mechanical, just a cable through the hinge, and then let the trailer brakes off, push it up onto the truck. Virtually the same as we do with jinkers to fold them up, pole trailers. We've gone on and built them for ever since. 1988, we built our first B double. We were first in Australia to put tandem in the lead and try on the rear. So we just used our folding skell on the rear and put a tandem in the lead. B doubles up to that stage always had try on the front and tandem on the rear. And that was, 1988. 1992, we did our first air winch. The one on the left was our very first one we did. Customer Gary Leeson in Victoria said, if you can put air winches on trailer, I'll give you an order for a B double. Put us in a situation where we had to design an air winch. That happens to be one of the worst things I've had to design, or most expensive things for what it is. We are to date in R&D $1.4 million out of pocket on that winch. And we're one of only 2 people in the world to build a successful air winch. And the other one's XT in Sweden. Remote release on the opposite side. And just turn it on. So very common now in the logging industry. In actual fact, there's hardly a new trailer goes out without it's got air winches on it. When it's up to tension, it keeps the tension on. As it goes down the road, it keeps tensioning. Try B doubles. We were out in 1993. In 1997, we were doing it fairly tough. I'd been selling gear into South Africa and took my eye off the ball a little bit here, and the industry slowed up. And we've been very good at getting a bigger share of a lesser market, but at that time we wasn't. So that time come around where there's a new rule, a rigid truck with a 4-axle dog and 50 tonne. I spent about 3 months in the drafting office trying to make a 4-axle dog fold up on a truck and couldn't get it how I thought would be acceptable. And we come up with this here as an Elphinstone little tandem dolly, a single axle dolly under the front of a jinker. And I went into Bert Elson at Transport Tasmania and said, could I have a permit for it? And he really gave me I don't know, Graeme, I can't do these things. And I said, for God's sake, Bert, we take risks all the time. You'll have to take some risk with us. And he gave me an undertaking and gave me a permit, and he said, now you must drive the truck for the first load, and if it doesn't handle right, you've got to take it off the road. You can't do those things today, and it's probably a pity sometimes because it does limit what we can do in development work. But out of that, we learned how to make a slider work So when we come up with a B double that slides up onto the back of the rear trailer, slides up rather than folds up, which really cut 2 tonne of tear weight out of our units, and put us back in a very competitive market again, because our competitors had actually copied our fold up. They still do fold up. And we went to this, what we called Easy Loader. For me in business, that was a turning point, because 97 we were doing it really tough, and we come up with this new design and took the risk of doing it. And that's still a flagship of ours today. To cover the 4-axle dog with the rule, which allows us to go on roads that a tri-B double cannot go on, I decided to just cut 1 axle off each of the 2 trailers, and it gives all the standard same components. And we ended up with an Easy Loader tandem B double, which really gives us the same configuration as a truck and dog. Only the most common log length in Tasmania at the time was a 5.5 metre log, and you can only get 2 bays on a normal 19 metre unit. So in I goes to Bert Elphinstone again and said, right, if we put a really short wheelbase truck on the front of here, we can meet the Ausroad standards for a 19 metre vehicle in turning circles. How about giving us 21 metres, and then we can get 3 bays on, and we'll save a heap of rollovers. And he again gave us a permit. But before we got them built, he had made it all 4-axle dogs, and many B doubles in Tasmania could run at 21 metres. Nowhere else in Australia can do that. So there's pluses on one side, there's disadvantages when you're selling equipment out of Tasmania to the mainland. You have to make 19 metre units. So the next thing, B triples. We had this basic design done in 1993, and I said to my draftsman there, let's forget this, we're way too far ahead of the market. So 2006, we put this on the road in West Australia, 27.5 metres long, and it self-loads when it's empty. It's a 1-finger operation in the cab to load it and unload it. That's slightly speeded up. It's 1 minute and 20 seconds per trailer to load them. And the same for unloading when they get to the bush. They unload. Obviously, the advantages are you get better traction, easier to turn around in the bush, and also a lot of times you can travel back via a route that's not a B double route, so you can cut time off travelling back to the bush. We then, 2007, pocket road train. So that's for West Australia again, 27.5 metres, and that's self-loading. The same prime mover can tow Easy Loader, tri, tandem, B triple, or pocket road train. Is a pocket road train here. We do a 30 metre version as well. Unlock the sliding turntable on the dolly, actually get it shortened up, and then unlock the slider at the back of the truck with a hitch on, and we've got an endless chain through a 40-to-1 reduction box at the front. That's a 30 metre version of it. And it's another, that's the 30 metre version. Then come along what we call the long logger. In Queensland, they were carting these 19 metre long logs on jinkers. Contractor won a contract to do them with 30-tonne loads. He rang me and asked me if I had some ideas, and we come up with this, give him a 45-tonne payload. We built 10 of these units for them. They carted 8.5 million tonnes of logs, 189,000 loads without any major incident. And a lot of the time we're on gravel roads. We did refine the design to a shorter pole than that one there, when we replaced them with another 11 new ones in 2020. And those are doing 8 to 10 loads per day, each unit. And currently they're carting about 100 V double loads a day with 15 trucks. They've got 29 tonnes of payload on the front bolster in the middle of the trailer. You ask a low loader operator to put 29 tonnes on a 1.2 metre square. When he's low loader, he gets a bit nervous. The rear trailer is a self-tracking trailer, so it steers from the rear of the lead trailer. When it's going around a corner, it actually forms a triangle, so it makes it a lot harder to roll over. Um, 2011-12 saw us, our forest industry shut down in Tasmania thanks to Bob Brown and his cult, they'll call it. And that made it very difficult for us. We went from building a trailer every 4 working days on the road to one every 28 days. You can imagine what that does to your business. So in desperation, I designed this trailer suspension, it's a self-steering suspension. And we aimed it at the highway workers, really not suited for logging. And we started designing this in November 2011. This is at Melbourne Truck Show in March 2012. For those that probably don't know, the National Heavy Vehicle Regulator has got a thing called PBS, Performance-Based Standards, that you can, as long as you can make a trailer perform within the normal rules, you can actually make it longer and it gives some flexibility. This unit here, a standard semi-trailer goes at 9.5 metre, we call S dimension, kingpin to the centre of the suspension. And this unit here can go out to 12.6 metres and still perform in the same turning radiuses around corners. And it was going to give us a bigger payload because we had the spread axle on the bogie at the back. So we're all simple form. It's a 3-axle dog with a turntable under the back and self-steering. Whoops, we might just go back here. We put it up to the NHVR, and this was going to save the jobs of our people at the time. So a standard semi-trailer is just a 3-axle at the rear normal. And then, although they knocked us back because it was it didn't suit the definition of a semi-trailer at the time. Definition of a semi-trailer is the tow vehicle will carry some of the load and there'll be one suspension unit at the back. Because we'd spread the axles out, it had 2 suspension units at the back, so they knocked us back for 3.5 years before they give us a permit. By that time, I had to put 14 people out of a job and 14 families, really, in a country town, which hurt. And I parked the stuff in the yard and forgot about it. And then next thing, people come out with this thing, just spread axles out on a rigid frame. This is a 2% grade, which is less than the crown of a road. That axle there is actually carrying the total load, and there's virtually no load on the rear on that sort of hump. Our easy steer actually has got a single point suspension in it. So when it goes over the hump, the suspensions virtually do no work, but they load share very well. There's a close-up normal suspension. That's 3.5% grade. You can see the front axle's run out of travel, so it's hard up carrying the total load, and the rear axle has run out of travel the other way. Anyway, we won't get too far into that. This is a good one here to see the difference in, this is what an easy steer does. Also, the spread axle one, they put standard 4-steer axle, which steers 12.5 degrees. One there in the centre, and the bottom is ours, which steers 25 degrees. Self-steering axles are locked up once they're over about 30 kilometres an hour, so they don't steer at high speed. Ours steers at all speeds. This will probably give you a good example of load sharing going out through a gutter and the tracking ability. I just thought some of this might, I presume most of your engineering people, show you a bit different engineering to boats. And some of the things we have to put up with in regulations, and I know you fellas have similar problems in your area. Regulators get in and wonder why sometimes. And so this is steered from the landing leg on the trailer. So the truck must be committed into a corner before the trailer starts steering. Yeah, and then they come out and allowed this thing as a quad version. And then they've allowed this one now as spread tandems. You see when you don't need a 2% grade or hump, the two axles in the middle carry the total load. So you can see this load being pulled off the truck. Makes you wonder sometimes. We built this as a 3-axle jinker in 2014. That also took a lot of fun to get through PBS. And we recently did this one here. And then we're now putting them into extendable trailers. And to give you an idea, that's the turning radiuses of a standard extendable semi-trailer going around on the red line, easy steer at the same length going around on the blue line. I think that's, one's at a radius of 8.67 metres, the other one's 9.35. It puts them into a different category. This is an experiment. We've been mucking around with a 6-axle dog. So the original trailer frame that we built in 2011 and another suspension unit that we were experimenting with, we just been hitching it up and playing with it as a 6-axle dog. Let's just go through that way. Excuse me.
What's next now? He's locked out. He's on the way. I apologise for that. He's got locked out. He's on his way back. Anyway, that shows some of the engineering of challenges that Graeme's faced.
What did we get to? Come to the end, did it?
Yeah, we're coming
Oh,
to you.
that one?
Graeme, maybe.
Okay.
Maybe.
Sorry about that. But it's been an interesting journey, this, and we've ended up with a couple of these easy steers on the road. One up in Queensland with Lord Transport's been there. We got it. Everything was approved, but the TMR took 5 months in Queensland to give a local road permit on just the main road. That went on the road May last year. It's done about 270,000 kilometres, and they just love it. They were, with the same truck, was towing an extendable trailers carrying power poles. They had a 24-tonne payload maximum on that. With Easy Steer, they could get 7 tonne more on it, although they're only carting 4 tonne more because that's what their contract is, so 28 and a half tonne. And their fuel usage on a trip from Townsville to Maryborough empty and back up loaded, which is 1,300 odd kilometres one way, their fuel usage went down by $120 per trip, plus their payload up by 4.5 tonne. The thing tows so much easier because it steers. But the future, I see one of the big markets is in road trains, and that's why, hence this here, there's road trains carting from Mount Isa to Townsville with very heavy ore. We've looked into that. We could, with the same number of axles, we can increase their payload by 20 tonne per trip. And the other thing in our experimenting, we believe, or it looks like, a road train normally, when it gets a weave up on the road, it amplifies through the trailers and you end up with a back trailer. It gets quite violent if you don't handle it right. And from experiments we've done with models, we built a 60-metre road train, a 10-scale model, been playing with it. My experience was that 4-axle dog, and you saw the weaving in the 6-axle dog. That's one of the standards. That was at 70 kilometres an hour when we weaved across the road. That's a standard you have to meet, with 60 kilometres actually, in PBS testing with a load. Now, although that didn't have a load on it, I know if I was driving it, I know it feels right. And I think from our experimenting, we think that the trailers are going to de-amplify, not amplify the rear amplification. That's just one of our latest displays now with on-vehicle weighing. In 1990, we developed all our own electronics, and we've been building our own electronics in Australia since 1990. We do manufacture some of our own load cells here. We machine them and we have our competitor gauge them, but the majority of our load cells are actually made in Seattle, where recently we've had to start our own company there because the company we're dealing with, having them made, took their load cell machining to India, and we didn't like that. So we've started our own company where we farm out and have the bodies machined and then heat treated, coated, and then gauged in all 4 different plants. We have all those load cells approved, all our own design.
That's in Seattle.
In Seattle, yeah. And I think it will only be a matter of time and we'll bring that manufacturing here.
Back to Australia.
Yeah. So one of the things I always like to do in my presentations is introduce people to, or highlight change. In our work, in our personal life, in our hobbies and sports, one thing that's sure is always something's changing. And as we're in logging, I obviously use this as a story. My father drove bullocks, pulling logs, and did it in his late years. He was a farmer all his life, but in his early days, he drove bullocks, and then he trained bullocks for his last, 20-odd, 30 years of his life as a hobby. But if we didn't accept change in logging, we'd still have bullocks. And the single axle trailer there is not the oldest in trucking, and gives an example. So if we didn't accept change, we wouldn't have the efficiency of what we've got today. And I think that applies to every business, really. And one thing that, all of us, sometimes we're a bit resistant to change. But I find what you've got to do, I've been guilty of making too many changes too quick, and that is bad too. So in business, I always look at it, you've got to know what to change and when to introduce the change. Otherwise, you screw up. If you introduce a change too early, the market will kill you. If you introduce it too late, your competitors are got it ahead of you. So there's a lot of about introducing change. All right, that brings us to the end of that lot. I could go on all night, but I think if you've got some questions, it'd be good to.
Have you got another slide on Antarctica?
I've got other videos on there. Is it right?
We'll see. Open it up to the floor. Yeah. Don't worry about it. You haven't got any more stuff on the Antarctic exhibition?
I believe so.
You're on mute.
Oh, you went.
Oh, so to the guys at AMC, do you have any questions for Graeme? We're going to open it up.
Right, you should be able to hear us now. Anyone, any questions?
Have you ever stuck a crane onto your trailers? I know the Americans have a few that make them self-loading.
A crane.
Yeah, self-loading crane.
We haven't actually put a crane on ourselves, but we do have a customer in Queensland. We built a what we call an easy loader fold-up jinker, and that has a crane on behind the cab that self-loads themselves. But we actually haven't put a crane on ourselves.
So how did the engineering in the trailers translate to the Antarctic gear and the sled?
Well, as you know, logging is a harsh application. And the experience from that was where I think Patrice Godden looked at wanting someone to build a different type of sled to what had been being built at the time. And because we've been in the forest industry and we do millions of kilometres, or our customers do with our trailers, he saw that as something that we may have the experience, and it's proven out. I think the Antarctic harshness is not as bad as logging. I can tell you. We've got sleds in Antarctic that have done over 200,000 kilometres on the snow. And really, it is a lot easier than logging because like they're doing 14 kilometres an hour is about the fastest they go. So you just don't have the stresses. We've got log trailers doing 100 kilometres an hour, and some of the drivers are pretty. Just hit the intro and it'll start. Yeah, they have some going where it gets a little bit rugged, more rugged, but we'll probably see a bit going through here. But in general, we've found it easier. And, and to give you an example, we've got 6B doubles in Albury, New South Wales, put on the road in 1999 that we know has done in excess of 8 million kilometres. They're well maintained. I'll just cover this while we're going. This is 100 kilometres inland on the French Traverse, and we're fully loaded there with fuel. I'm actually driving the tractor that's in the view here now in that. So that's one of the very rare video clips when they're fully loaded, all the fuel tanks. I'll just skip that because we saw that before. So like I said, I've been lucky enough to have 4 trips down there, and I've driven machines into Dome Sea 4 times. A Challenger 65 first time, picked up all the empty fuel tanks coming back, 15 fuel tanks behind me when we got back at the finish. The second time I drove a Casbora grading the road. Third time I did a Casbora, done about 3,600 kilometres of road grading. And last time I drove an 865 Challenger. I guess all of you are really reasonably familiar with the Antarctic layout. Obviously, Hobart to De Montville for the French, and the the US around in Ross, McMurdo, and then Italians, and they all got bases around there. The trip into Dome Sea is 1,100 kilometres, the orange line there. So you can see it's a massive, big place. Dome Sea is 3,200 metres above sea level. So you climb about 2,000 metres in the first 250 to 300 kilometres, and then you gradually climb the other 1,000 metres. Temperature at the coast is around the -5 is normal. Once you start going inland, it's -20, -25 fairly quick, and then it gradually gets colder. Dome Sea is -40 in the summer, -80 in the winter. Give you a bit of an example. Also, Dome Sea, there's very little wind. About 20 knots is about the strongest wind they get. So they figure everything in the ice there is actually fell out of the atmosphere. That's why they're all going there and drilling for the oldest ice in the world and getting the core samples. There's also a site there where they calibrate the satellites from around the world. So it's sort of a lot of interesting things. I'll give you an idea where Casey, Davis and Mawson is the Australian bases. And it's quite interesting because De Montville to McMurdo, the Concordia station's 1,100 kilometres. From McMurdo to there's about 1,100 kilometres. And then I flew into McMurdo on a second trip down with the American Air Force, and then flew into Concordia and then flew back up to De Montville. The last time I went down, we flew into the Mario Suzuki, the Italian base on the Ross Sea, and then flew across to De Montville. This is typical going in on the old Lastrolab, getting into pack ice. This is coming out actually, but it's the same type of. I'll skip through some of these because otherwise it will take a fair while to go. But some of the De Monteville and some of the ice outside. This is in pack ice. 27th of December 2016. This is. I just got back on the ship after doing a traverse. It was 116 kilometres out to sea. This is. No flying stuff in. Unloading on the sea ice. Typical there. Some of the videos you saw before are here. This is out on the sea ice. Like I said before, they had 3 years they couldn't get into the base with fuel. So they got a bit desperate for fuel, and that's how we built these air sleds for them. We built lower air sleds for them, and this last couple of years we've been experimenting with close foam instead of air, because the problem with air in the sleds, in the tubes, when you're going up a higher altitude, you have to keep lowering, letting the air out, and coming back, you have to pump them up. So there's pressure.
Air sleds, is that in the suspension? Or?
They're just air tubes.
Just air
Think of a Zodiac, and you've got the air tubes on the side. We've just got long tubes along underneath. This is that's an air sled behind this here. Yeah, I think we'll go through here. Carpets. There's more interesting stuff in here. That's the video you saw before. Again, this is Dome C. So those buildings there are 3 stories high. They dug out 6 metres deep and then compacted the snow and built these buildings on them. They're on really big cylinders underneath and hydraulic rams on each side, so they can actually level the buildings if they ever sunk, but they've never had to use them. The aircraft there is a Basler, so that's an old DC-3, about 1953 model, converted to a turboprop, upgraded, and they call them a Basler. Pilots love them. There's more interesting stuff in here in a minute, I think. Traverse. It takes 12 days to drive the 1,100 kilometres inland. You usually only do 50 kilometres, 60 kilometres a day the first few days when you're really heavily loaded and heavy pulling. Once you get up on the plateau, usually around 100 kilometres a day. This is the living quarters. The front one there is the, they call it the caravans, 30-foot freezer container, really, about 3 metre wide. 4 bunks in each end and a kitchen in the middle, and table to eat. The pumping gear on the side there is for pumping fuel. And they use about 110 cubic metres of fuel to do a trip in and back. So and that's with 10 machines. Each night when you pull up, you fill up with fuel. So the standard.
So you transfer fuel to the vehicles.
Yeah, from the tanks. The first, and on the rear there is with the, you can see snow sitting on the back. That's a snow melter. So at night time when you pull up, they push snow up behind, and you shovel it into the snow melter, get your water. And typical day starts about 7:30 in the morning, warming up machines. They like to be hooked up, ready to go about 8:15 of the morning. They drive non-stop till 1:30, 1 hour for lunch, then start again and normally drive till 8:30. And then it takes about an hour and a half to refuel and tidy things up. This is the kitchen inside those living quarters. Typical of a machine. This is obviously the downwind side. The snow blows over the bonnet, melts, runs down the side and freezes. This is on the last trip I was down there, we met the Italians going in as we were coming out. It's the first time apparently it's ever happened. The 2 traversers met. And we you're right. lost. Right. Yeah, we met the Italians. They were going in. We actually transferred 26 cubic metres of fuel across to them there and had a coffee, and then they went on their way and we went our way. That's a Casbora. Yeah, I really enjoyed driving these things. But you were doing about 13 hours a day in a Casbora because you had to grade all the snow away. This is typical. There's one out in front. There's one after some of the sleds have been across grading the road. This is a snow groomer we've got on the back of one of our air sleds. They were having trouble with the air sled. Big carpet was making the snow too flat and they were having trouble getting traction. So we're cutting little grooves in it so that it allowed the tractors to get traction coming back. This is out in front when the lead snow groomer has to push a lot of snow. This is driving in snowblow. So when you get a blizzard, it just is white out. And this gives you a pretty good example. As long as you can see a colour up in front, you can see, but if you blank them out, you can imagine it's just white and it gets worse. And if you haven't got some colour in front of you can't see anything. So you can imagine the lead tractor, he has to work on GPS. You can see there. Yes, you do. They have really strong lights that on some of the tractors. This is a good example in blizzardy type conditions. But yeah, they have a really big strong lights, but they're not a lot of use in just daylight. It's good at night time, or when you're coming back on the second traverse, it's starting to get dark.
How many hours of daylight?
24 hours a day, normal, but once we're coming back in February, it's starting to get dark from about 9, 10 at night. It closes in by about 20 minutes per day once it starts getting dark. The fuel tanks, we build all the axles and skis for these and the turntable on the front. That's one of our air sleds. And like I said, we're experimenting now with closed foam underneath those. Gives you a bigger load capacity, less ground pressure.
So what material do you have underneath the air sled?
Just a polyethylene.
Just like a
plastic, big sheet of plastic.
Big sheet of plastic.
For simple terms. Probably the other thing that under our skis, we have plastic on the bottom of skis. So a ski creates heat from the friction. When you stop, it melts the snow and then freezes, and you can't take off because it's stuck to the steel. So that's the reason to have plastic on the bottom. For all intent and purposes, you can picture skis going through the snow is just like a boat through water. There's no wear, really. The only time they damage anything is when they get them on the rocks down near the coast, or someone drives a Casbora blade into the side of them. These are some of our building support structures that I said about before. We do them in flat pack and they just bolt together, and they're made so that 20-foot containers sit on top. We do have made frames in the same base as a 20-foot, like a flat base for a 20-foot flat rack type thing, and building a building structure on top of it, as well as containers. So that one there is the equivalent to 38 containers. This is interesting. The icicles down the side there are caused by the wind is blowing the snow, the dust. It's just like dust from a dusty road, drifts up the side. The sun on the side of the container melts the snow, runs back down. As soon as it gets where the air is, it freezes. You've got something that a lot of people just don't come to grips with. It's totally dry. You can lay in the snow all day under a machine working and it won't get wet because it is totally dry. And that's what people, that's why they say Antarctic is the driest place in the earth, on Earth. It's that cold that it's totally dry. As I said before, the Australians
They're all your trailers.
They're all our trailers, 100%. Oh, obviously containers are not, but you can see the slave sleds stacked up here. Or now they call them base sleds. And drawbars on the top here go onto the front of those sleds. We build the aluminium walkways, aluminium stairways, you can see there. The racks around the sides, they're all modular, bolt on. The 6.5 metre sleds are built for 25 tonne load capacity. The ones we actually build for the South Koreans are 20 tonne. They've got smaller skis on them. These are larger. And we build a 12.5 metre one for the Australians to carry a 37 tonne payload.